So today we're going to talk about dividing polynomials, and you'll see right here that we have a trinomial actually divided by a monomial. The best way to get this problem done is to rewrite it in a vertical fashion, or at least that's the way I choose to do it. 2y squared minus 3y minus 9 over 3y. Whenever I have a term split up by addition and subtraction divided by a singular term, I can take and rewrite as three different fractions. So let's do that, and then I'll take and reduce each fraction individually. So I have y squared over y, which is a y, and I have my 2/3 left. 3y over 3y is just 1. 9 over 3 is just 3 with a y in the denominator, and that'll do it. Second term, same type of example. Break it up into three separate fractions. So I have minus 15ab cubed over 5ab plus 10a cubed b to the fourth over 5ab, and reduce each one of these, noting that the exponents on the ab term in the denominator are both 1. 5 over 5 is 1. I'm left with an a. And the next I have 3. The a is reduced, but I have b squared. And lastly, the 10 and the 5 reduce to a 2. A reduces to a squared, b reduces to b cubed. So now we're going to divide a trinomial by a binomial, but you'll notice in this case when I rewrite it vertically and look a little closer at the term, I notice that there's always a possibility this top term is going to factor, and in this case it actually does. You can do a 5-step, or you can do a guess and check if you want. I'm just going to do my guess and check. So the top term factors into 2r minus 1 and r plus 3. Notice these are like factors. It's almost just like if I had a, b over b. The b's would reduce because those are like factors. Likewise, if these are exactly the same, I can reduce them. So I reduce those out and I have 2r minus 1. And that's only going to happen if you take in factor. I can't split this up into three separate fractions and reduce. So let's go back to, what, 4th or 5th grade, do a little long division practice, because we're going to, after we get done with this problem, we're going to do it with a more algebraic type of problem. So again, back to 4th grade, we would say 13 times what is 40? We would say 3, multiply, get 39, and then subtract. Bring everything else down. 13 goes into 12 how many times? 0 times, so we put a placeholder there. And then we'd say, well, 13 goes into 123 how many times? And that's going to go in 9 times, which gives me 117. Do the subtraction again, we get 6 and a 4. And then 13 goes into 64 4 times, and we multiply to 52, subtract once again, get 12, and that's our remainder. Now when we apply this to polynomials, we have x squared plus 7x minus 15 over x minus 2. And in this case, we only really look at the first term and we say x times what gives me the first term over here. So x times what gives me x squared? Well, that's an x. Now we replicate what we did in 4th grade. We multiply this term by the entire number. So that's x squared minus 2x. And again, like in 4th grade, we're going to take and subtract. So when I subtract these two, I get x squared minus x squared, which is 0. I get 7 minus a negative 2, which is like 7 plus 2, or 9x minus 15. Again, we're going to ask x times what is 9x? And that's a positive 9. Multiply the 9 to the entire term, giving me 9x minus 18. We subtract once again. 9x minus 9x goes to 0. And negative 15 minus a negative 18 is like adding 18, or with a remainder of 3. So, a couple ways this can be written is x plus 9 with a remainder of 3. More commonly, you'll see x plus 9 plus 3 over x minus 2. And this acts like our remainder. So let's do another one. This one's a little bit different in that you'll notice I go x cubed to an x to a 45. There's no x squared term here. And what we should do whenever we're missing an exponent term is put in a placeholder. So this is like x cubed plus 0x squared minus 34x plus 45. And you'll see why this comes in handy in a second. X times what gives me x cubed? That's an x squared. I multiply, I get x cubed minus 5x squared. Had I have not had this placeholder, I could make the mistake of lining it up under the x term and then adding or subtracting those, but I don't want to do that. I have my placeholder here. I'm subtracting 5x squared, and now I can go ahead and subtract. X cubed minus x cubed goes to 0. 0 minus a minus is like a plus 5x squared. Bring everything else down. Say x times what is 5x squared? That's just 5x. So I have 5x squared minus 25x. Subtracting again. 5x squared minus 5x squared is 0. 34x minus a minus 25 is like adding 25 to that. So I end up with a negative 9x plus 45. X times what's negative 9x? That's a negative 9. Multiply, it's a negative 9x plus 45. Negative 9x minus negative 9x is 0. 45 minus 45 is 0. This is the first time we've had a remainder of 0. Therefore, if I have a remainder of 0, then term is a factor. So in this case, x minus 5 is a factor. The remaining term is also a factor. It's like saying if I have 6, then 2 is a factor, but so is 3. So now, if our divisor, the term outside the division sign, is in x minus a form, I can use this thing called synthetic division. It's a little bit quicker than the long division we've been using. And we're going to take an example like this: x cubed minus 4x squared plus 6x minus 4 divided by x minus 2. This is in x minus a form. So in synthetic division, you're basically going to write the coefficients of the dividend so that the degrees go in descending order. Here's your dividend. So coefficients are the numbers out in front: 1, negative 4, 6, and negative 4, and write them in descending order. Then we're going to take and put our divisor r into a little box and bring the first coefficient down. We multiply the first coefficient by r, write the product under the second coefficient, add the product of that and the second coefficient, and then repeat until we're done. This makes no sense until you really see it, so let's do it right now. We take and write the coefficients in descending powers of x. So I have a coefficient of 1 for my x cubed, negative 4 for my x squared, 6 for my x, and negative 4 for my constant term. This was in x minus a form, so a equals 2. We put 2 in a little box out here, and then we bring our first coefficient term down. Now, here's our repetitive process. We take the 2, multiply it by this number here, put my answer to the product under that next coefficient term, and then we add. So this is negative 4 and 2, which is negative 2. Then we repeat the process. 2 times negative 2 this time. Product goes under the next term and add. 2 times 2 is 4 and add. Notice, since we get 0, this term is our remainder. Therefore, x minus 2 is a factor. Now, what's my solution though? Because I just have numbers now. Well, it turns out that if this is my remainder, then I go backwards in ascending powers of x. So our first term is a constant. Then this is x to the first and x to the second. So my answer is x squared minus 2x plus 2. And I know that if this is a factor as well, then x minus 2 times x squared minus 2x plus 2 is equal to x cubed minus 4x squared plus 6x minus 4. Do a couple more examples. Again, it's just written a little bit differently in a vertical form, but I do the problem the same way. This is 3, negative 2, 1, and 4. This has to be written in x minus c form. X plus 1 has to be written in x minus a or c or however we want to, x minus a form. So I know this is x minus a negative 1. We've seen this trick before. So therefore, a equals negative 1. And that's what I'm going to put in the little box out here. We bring down that first term, and now we multiply, get a negative 3, add, get a negative 5, repeat the process, 5, add, get 6, multiply, get negative 6, and negative 2. Therefore, we have a remainder in this case. X plus 1 is not a factor. This is my constant term, my x to the first and my x to the second. So my solution is 3x squared minus 5x plus 6 plus negative 2 over x plus 1. Last one. Now you'll notice in this case, look at the degrees. I go from a fourth power to a third power, skip the second, first power, and x to the 0 or constant term. Like we did in our long division, we need a placeholder. So I have 1 for my coefficient of x to the fourth, negative 2 for my coefficient of x cubed. I don't have that x squared coefficient, so I need a placeholder of 0. 13 for my exponent of 1, and negative 6 for my constant term. Again, we need this to be an x minus c form, so x minus a negative 2. Therefore, I put that term in the box. Bring the first term down, multiply, get negative 2, add, and get negative 4, multiply, get 8, add, get 8, multiply, negative 16, add, negative 3, multiply, get 6, add, get 0. Therefore, x plus 2 is a factor. And my solution now, if that's a constant, x to the first, x to the second, x cubed, is a third degree polynomial of x cubed minus 4x squared plus 8x minus 3. That's my solution, and I also know that x cubed minus 4x squared plus 8x minus 3 multiplied by x plus 2 is going to be equal to x to the fourth minus 2x cubed plus 13x minus 6. And that's it for long division and synthetic division. Do your Connect Ed and write your lesson summary, and we'll talk more tomorrow.